Hi everyone. I'm glad to be here. My name is Ziqi. I'm currently in the last year of my PhD in Polytechnic University of Madrid. So today I would like to introduce you free tool, TreeProfiler, PhyloCloud, and ET Toolkit to hope to enhance your phylogenetic analysis. So as we know, the phylogenomic data has been growing rapidly over the past decades, and it's more and more common than genome-wide projects generate hundreds, even thousands of trees. So some of trees can be also large in size. So there are some of these challenge we encounter in our study during in our lab. So here are some of them. So first of all, huge tree is very difficult to visualize. Here we showcase one example that it's a tree with 7,000 tips open in a very common phylogenetic viewer. So as you see we see the right panel, and you can see when it collapses. When we zoom in, the branches are collapsed and stick together, and they become unreadable and difficult to extract informations. So, and second, apart from the tree, we also hope to visualize and analysis the annotations file on the tree. So now most of the annotations only exist in the leaf node. When during visualize the tree, sometimes we need to prune, we need to collapse, and what to show and how to summarize those information in the internal clay has become difficulties or unclear situations. And the third, we hope to build some user-friendly methods for handling data, so it's easier to use, because most of the times, currently those are phylogenomic analysis pipelines still realize on user with a programming background. So based on those challenge, we developed something called ET Toolkit ecosystems. So basically, we have a free tools. Each one we have a different focus on the challenge we mentioned before, but they are all more or less connected with one drawing engine. I will introduce you in the following slides. So first of all, huge tree visualizations. So in our lab, we host ET Toolkit, which is a Python framework for analyze and visualization of trees. And this year, we are marching to version 4. In the biggest features we have in the version 4 is we are adopting a new tree drawing engine, which have adopted zooming algorithms to allow us to visualize maximum 1 million nodes, and also provides interactive interface and visualization version. So the version 4 beta version is already released on the GitHub. So here I have prepared a small video to showcase how it looks. So here we open a tree. It's a GTDB tree, a bacteria tree with 45,000 leaves. So it's 6 times larger than the tree we failed to visualize. It's a zoom in, and then we can see all the clay is very clear, all the leaf is very clear to see. And then as we zoom out, because of adaptive zooming, and they will collapse, but user can expand them in the panel. And then we show the circular, here we show the circular mode with ultrametric. As this morning we see the beautiful sugar beetroot tree. It's so that's one of that's something I hope to do that in here too. So this is also we provide some on-fly functions, such as searching the clay, searching the tips. So and then we provide, so in the interactive panel, then you can choose, user can choose a color and do a lot of different things. So here is a static versions. So you can see if the tree have internal node, the nodes properties, like customized properties. It will show also, you can show when you hover or click on the clay. And then if you right click, also we have a node panel, which is you can outgroup and do all the printing using the node panel. And second, how do we visualize and summarize those tree annotation from leaf to root? So Based on this, we built a command line tool called TreeProfiler. So it's a command line tool for annotation and visualization, phylogenetic tree, and metadata. So basically, we have a phylogenetic tree with our metadata, hopefully tab limit TSV file. So we TreeProfiler have two steps. The first step is we annotate it. So from leaf to root. So the TreeProfiler will summarize the metadata information from leaf to root. So the parent nodes will will do statistic to summarize those data from their children nodes. So and then we output a intermediate file called annotated tree as a Newick file. So then after that, user can visualize their annotated tree in other software or stick in a tree profiler, which we will visualize using the ET4 drawing engine. And we also already published this release it on the GitHub, and we will submit to the journal very soon. So here is another video to showcase the same GTDB tree, bacteria tree, but this time we will annotate the associated metadata from GTDB. They will over 100 features. So, but this video is enhanced with, accelerates with a speed of 1.5 because I don't want to exaggerate the performance, but I have a limit time. So here we see one command line. So here we tree, it's a visualize with this color clade means that the rank classifications and all the metadata such as genome size, protein count, GC percentage, this numerical data we show as a bar plot or heat map. And then for the categorical data, and then they will show as such as horizontal stack bar because the categorized data, and also all the heat map for the Boolean data. And as we can see here, and then if the tree nodes here are collapsed, so for the layout panel, what it shows actually is the summarized information of the internal nodes. But when we zoom in to the leaf, and then the layout will change accordingly. Now it's become the leaf metadata. So, and in this case, we can see all the metadata at the same time. And then also when we do pruning or collapse, they will automatically have the internal nodes informations. And all the legend it will show also on the panel. And here we manipulate a little bit, try to achieve the publication levels. So here, that's how, let's see. Yes, so here, that's a few steps. We show the whole GTDB bacteria tree with some of the select features. So because of the time limit, I cannot show you everything of the layout we have, but based on different data type from the metadata, we have a categorical data, numerical data. If it's categorical data, we also provide such as percent absent matrix, and then multiple sequence alignment layouts, domain annotation layouts, taxonomy. And also, this is an example we showed using the ECCB mapper functional annotation output to annotate it on the tree. So you can see this is especially here is like the CAC pathway, the basic categorical data, and then also the circular layouts and the domain data. So in order to build an easier version for the people using web server, so we built one called PhyloCloud. So PhyloCloud is an online platform. So user, if you have your phylogenomic project, such as trees, alignments, so we can upload to the database, to the web server, and then each data will all the trees will generate collections of auto indexing, so you can search on your own database. And then each tree, we have a tree profile page. so you can visualize and editing. And also we provide some predefined annotation and analysis, so user can just click and then do some of the annotations, and all this information can be saved back to the database. And also we can share to the public or your colleagues. And we published the PhyloCloud last year. It's already online and running. We have approximately 100 users. So to summarize, so based on this large tree drawing engine, we have one Python library, a command line tool, and a web server in order to solve different challenge. But you can see they're all surrounding in a large tree drawing engine. And then so it based on the different programming demands, and we have different differentiate to different tools. And can we do more? Of course, yes. We hope to use this as an ecosystem, and then so we built more applications or attacked more challenge, such as like sequence placement and ecological profilings. And also for the data repository, we see that this ET4 can be a good fit, such as to visualize large trees, such as tree of life, also in the eggnog database, and also now it's also in a genome browser. So we will have some collaboration on this. And I would like to take a few seconds to thanks for my co-workers, especially my supervisor Jaime. He presented this idea, I believe, in ISMB 2019 in Basel, but back on then just prototype. And then I started a PhD with this project, and Jordi come to improve our drawing engine. So I build a useful thing based on their shoulder, so I cannot work. So I appreciate them, and also my other co-worker. They constantly give suggestion and support. So thank you very much.
Let's take one question before the break. Thanks. So let's take one. Do you have documentation for version 4?
Oh, that's a very good question. So to be honest, so the last version of ET3 published in 2016. And after that, our documentation stay on these versions. So if you just go to directly to ET4, you will encounter numerous of unpleasant experience. So that's why this is my job, one of my job in the summers. So finish the documentation, to writing the documentations, and also my email address or everything contact is there. So very welcome to contact me. It's now I'm the maintainer of free of these tools. So it's so yes.
Good. I'll ask you this question a year from now again.
Yes. Well, yes. I'll try my best.
Okay. Let's thank the speakers again.